Hey, how's it going? All right, we are still in Unit 8 and we're still talking about functions. And this time we're going to talk about function construction and modeling. What we mean by function construction and modeling is we're going to build functions that model real life situations. So we're constructing functions that are modeling real life situations. So to give you an example of a real life situation, let me tell you about last summer. So last summer, I went to the Orange County Fair and it was pretty fun. But the one thing that's kind of a bummer is you pay like $15 to get in the fair. But if you want to do anything fun, like go on the rides or anything, you have to buy the tickets, and that costs even more money. So, like, you have to pay a lot of money if you want to do anything kind of fun. Well, when you're going to the fair, the amount you spend to get in the gates doesn't change. It's $15. You pay the $15, and it doesn't matter what you do once you get in the gates. The $15 is the same that everybody pays. So some people just pay $15, they go in the gates, and they don't spend any money. They just walk around and they look at the homemade quilt contest or whatever they might think is fun, and then they leave. And the cost of going to the fair is $15. But for most people, they might want to do some more fun stuff. And the money is going to be more than $15 this time because you've got to add in the amount you spend on tickets. And the amount you spend on tickets depends on how many tickets you purchase. And so we have to use a variable for that because you might spend a certain amount of money on tickets and I might buy a different amount of tickets than you. So since it can change, it's a variable, we could call it T for the number of tickets you buy. Now, each ticket $2. So, if you buy one ticket, you pay $2. If you buy two tickets, you pay $4. If you buy five tickets, you pay $10. Whatever the number of tickets is, you multiply it by 2, and that's how much money you spend on tickets. And without even really realizing it, guess what we just did? We just made a function that models this situation about how much money you spend going to the fair. Now, I'm going to switch out that f of x notation though, because I think for this situation, since we're talking about how much it costs to go to the fair, we should probably use a c, because the cost of going to the fair is a function of how many tickets you buy. So instead of f of x, let's call it c of t. The cost of going to the fair is a function of the amount of tickets, t, that you buy. Oh, so we just constructed a function, we just built a function that models a real life scenario. Now that we have a function, we can figure out what does it cost to buy 10 tickets? Well, if you bought 10 tickets, you paid $15 to get in the gates, plus $2 for each of those 10 tickets, and 2 times 10 is 20. 20 plus 15 is $35. That's the cost of going to the fair and buying 10 tickets. It's a function. It's a number machine. You put a 10 in and you get a 35 out. But what if you buy 20 tickets? Well, now you're just going to plug 20 in for t, and so it's going to be 15 plus 2 times 20. So 2 times 20 is 40, 40 plus 15. You put a 20 in for the number of tickets, you get a 55 out for the amount of money that you spent at the fair. Notice this real life situation has part of a function that's just a regular number, it's a constant, it's 15, and part of the function is a variable part, the 2t. Alright, what you could do if you got real crazy with this is you could even put it on a graph. So if you wanted to figure out how much money you're going to spend, well, right off the bat, you're going to spend $15, right? Even if you didn't buy any tickets. But if you buy one ticket, you spent $2 more, didn't you? And then if you buy another ticket, you spent $2 more. And then if you buy another ticket, you spend $2 and then $2 and then $2 for each additional ticket that you spent. So this is a function that happens to be a linear function that models the cost of going to the Orange County Fair. I think that makes sense. So all you have to do is now try to construct a function that models the following situation. So I'm going to give you a situation. You're going to try to make an equation, a function equation, that models it. Or you could model it by sketching the graph of the function, or if you're really extra special, you could draw the graph and write the function equation. All right, are you ready? Here is the scenario. Penelope doesn't have any friends. She's starting to feel pretty sad. So she goes to the local Rent-A-Friend store. To rent a friend for a day, they charge $50 flat fee, plus $5 for every compliment the rental friend gives you. How much would it cost Penelope to rent a friend for a day and get 7 compliments? All right, here's what you need to do. You'll probably want to pause this video, reread the question, look at the numbers, figure out which part is the constant, which part is the variable, and then go ahead and build a function equation. All right, that's all we got to do. Hope you enjoyed today's lesson, and I will see you all tomorrow.